Okay, let's talk about product and division of two series. Now, before we look at some examples, what I want to mention is that for division of two series, essentially it is also a product of two series. Okay, what do I mean by that? Now, for example, let's say if I would ask you to take EX, divide by, say, 1 plus x. Okay, now what happens is this is a division, okay, of two series, okay, which you can expand using your MF26 formulas, okay, from the Maclaurin expansion, right? But before you could do anything, okay, make sure that you, or rather I should say, before you substitute those series into your EX and 1 plus x, you should put it in this form: 1 plus x, okay, to the power of minus 1. All right, so essentially now you're looking at the product, okay, instead of a division. So just remember that, okay? So whenever you have a division of two series, make sure you actually manipulate the power, okay, or rather the indices of the denominator, so that you actually make it as a product of two series. Okay, now let's take a look at an example. So like I said, product and division is almost similar, okay, except for this extra additional step that I've just mentioned. All right, now again, with product and division, the steps are the same. Okay, step one is that we would, if it's divide, okay, if it's a division, okay, what we need to do is that we need to turn it to a product, and this one happens if it is a division. If not, if it happens to be a product straight up, you will skip this step and move to step 2, right? And step 2, again, you will expand and simplify, right? And simplify, okay, each of the series independently. Okay, I'm going to squeeze in here, independently. All right, and then step 3, we are going to do the multiplication. So multiplication, all right, using the rainbow method. Okay, all right. So now, as with this topic, I think it's best to learn this through an example. So let's take a look at a question. All right, I'm gonna use blue this time. Suppose we are given ln, all right, 1 plus x over 4 minus x squared. Okay, so this is actually a division, but like I said, we must turn it into a product by manipulating the powers for the denominators. So using the laws of indices, we know that it is simply ln 1 plus x, okay, and then we multiply that. Okay, I'm going to put a square bracket here so that there's no confusion. All right, so this is a term, and then we have the 4 minus x squared, okay, to the power of minus 1. All right, so now we have a product of two series. Now, we're going to go ahead and expand this, okay? So the ln 1 plus x is actually easy. We could just copy this one down and say that, suppose the question asks us to expand and simplify this so that we get the expression up to and including x cubed, okay? X cubed, all right? So in this case, we will just go ahead and copy down the ln 1 plus x since it's exactly that. So that will be x minus x squared over 2 plus x cubed over 3, okay, plus dot dot dot, right? And a close bracket. Now, some students might be wondering, hey, but this is a minus. Should I actually put a minus dot dot dot? In this case, it doesn't matter, okay? Like I said, we are not so particular about the unspecified terms at the back. All this means is that there are some other terms, okay, that goes on, all right? Now, after that, we got to do this, right? And in the previous lessons, we actually talked about making this ascending powers of x, okay? So in this case, we are looking at this guy, but before that, we need to make the first term 1, all right? And that means that we need to pull out a 4, okay? So we need to pull out a 4, all right? And then that gives us 1 minus x squared over 4, right? So if you multiply that in, you get back 4 minus x squared. And then this whole thing to the power of minus 1. All right, now we're gonna simplify that a little bit further. Okay, so let's just copy the ones in front, plus dot dot dot, and then we're going to simplify this. So that will be 4 to the power of minus 1. Okay, that gives us a quarter. And then after that, 1 minus x squared over 4 to the power minus 1. So for this guy, we are ready to use this expansion from our MF26 over here. Okay, so we would have a quarter. Let's write it at the start. Then we have x minus x squared over 2 plus x cubed over 3 plus dot dot dot. Okay, and then we're going to expand this guy, right? 1 minus x squared over 4. So we will replace the x with minus x squared over 4, okay? So the first term would simply just be 1, okay? And then it says plus nx. What's n? N is the power, so it's right here. So in that case, our n would be minus 1, okay? So let's change this to a square bracket, okay? So square plus square bracket and then 1 plus, okay, n would be minus 1, and then we have x. Remember, we're going to replace x with minus x squared over 4, okay? And since we need up to x cubed, we can go down the series, okay, and get more terms. So that will be n times n minus 1 over 2 factorial, okay? That will be n bracket n minus 1 over 2 factorial. So we, in this case, will have a minus 1, okay? Then n minus 1 will be minus 2 over 2 factorial, okay? And then we have x squared, which is minus x squared over 4. We replace x with x squared, minus x squared over 4, then we square this, okay? Now, the thing is, if you look at this, we actually don't need this anymore, right? Because although this is x squared, okay? But because the term that is on the inside is x squared, by the time we square the x squared, we will have x to the power 4. But all we need is up to the x cubed term. So we can actually omit this, all right? So I just did this little exercise just to illustrate that sometimes, you know, this kind of things happen. So this is great news for us, right? Because then we have actually less terms to evaluate. So again, we are going to simplify this a little bit before we do step number 3, which is the rainbow for multiplication. All right, so dot dot dot, then we have 1 minus minus gives us a plus, okay, x squared over 4 plus dot dot dot. Okay, cool. Now next up, we're gonna move on to step number 3. Okay, let's just scroll this up a little bit, and we have, let's keep the 1/4 on the outside. Okay, so now let's take the first term. Okay, let's do it in red for underlying this. Well, let's take the first term and we'll multiply, we'll use the rainbow method and multiply it to the first 2 terms in the next series. So that gives us x, oh, let's put that in blue. Okay, that gives us x, okay, plus x times x squared over 4. That gives me a quarter x cubed, okay? And then after that, we move on to the next term in the first series, which is minus x squared over 2. And we're going to multiply that again to the terms in the second series. But you realize that in this case, all we need to do is to just multiply it to the first one, okay? We don't need the second one, okay? Because x squared times x squared gives me x to the power of 4. So we don't need that. So that leaves us with just the first set, which is minus x squared over 2, okay? Minus x squared over 2 times 1. And then that's it, we can stop there, all right? I'm just gonna undo this, okay? So remove some clutter. Okay, oops. All right, now let's move on to the third term. So of this first series, so we have x cubed over 3. Again, we just need to multiply that to 1 to get x cubed over 3, okay? We do not need to do this one because x cubed times x squared gives us x to the power 5, which is higher than x cubed as required by the question. So we'll stop there, all right? Then we'll do the plus dot 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 and close the bracket. So it's kind of telling the whoever that's reading this that we're consolidating all the unspecified terms at the back. Okay, now with that we can simplify this again. We've got x Then we've got minus x squared over 2. And then we've got a plus 1/4 x cubed plus 1/3 x cubed. So we can type this into our calculator. 1/4 plus 1 over 3. Okay, so that gives us plus 7 over 12 x cubed. All right. Now we can expand this some more. So that gives us a 1/4 x minus 1 over 8 x squared plus 7 over 36 x cubed plus dot dot dot. And there you go. This is the answer. So with this example, I hope that it's clear how to carry out a product or division of two series. Just remember, if you have a division of two series, always mix it into a product form first. All right?